This is Unit 9, Lesson 5, your Intro to Probability. What is probability? Well, we can determine the extent to which an event is likely to occur, that is, the chances of an event happening, using measures of probability. So mathematically, the probability of an event is a ratio. It compares the number of favorable outcomes, that is, what you want, to the number of possible outcomes, that is, what you could possibly get. So we will be writing it as a fraction. You can see the notation P, and then in parentheses whatever the event is that you're talking about, and then the ratio of favorable outcomes over possible outcomes. Example 1. We've got a bag full of marbles. 7 are pink, 2 are white, 6 are blue. So we're going to select a marble without looking. We're going to find the probability of each event described below. So first off, probability that the marble we select is blue. First of all, we have to figure out how many marbles are in the bag, so you add together 7, 2, and 6 to get 15. There's a total of 15 marbles. So the probability of it being blue is the number of blue marbles over the total number of marbles. Number of blue is 6, total is 15, so the probability of it being blue is 2/5. We always want to simplify our fraction. We also like to write it as a percentage. 2/5 is 40%. All right, how about the probability that it's not blue? Well, in that case, it's the number of marbles that are not blue over the total number of marbles, which is 9 are not blue out of 15 total. Simplify that, we get 3/5, and so translate that into a percentage, and that's 60%. All right, example 2, we've got this spinner, and it's spun once. We want to determine the probability of each event indicated. I'd like you to give these a try. Express them first as a fraction in simplified form and then as a percent. So go ahead and stop the video and complete that. Turn it back on when you are finished. All right, let's see how you did. The probability that you spin a 6. There are 10 numbers, only one is a 6, so the probability is 1/10 or 10%. The probability that you get an even number, well, out of those 10 numbers, 5 are even, so 5/10 is 1/2, 50%. Greater than 6, there are 1, 2, 3, 4 greater than 6 out of 10, so 4/10 simplifies to 2/5, and that's 40%. All right, the complement. The complement of a set is all the objects that do not belong to the given set. So in example 1, the complement of drawing a blue marble is drawing a marble that is not blue. Now, just one note here. The word complement mathematically is spelled with an E in the middle of it. If you want to tell somebody that they look fabulous, that's giving a compliment with an I. So back to our complement. The probability of a set and its complement is going to always add up to 1. Let's take our example, blue and not blue. The probability that it was blue was 2 out of 5, and the probability that it was not blue was 3 out of 5. When you add those together we get 5/5, and that's a whole of 1. And that makes a lot of sense because if a set and its complement are the set and all the ones that are not in it, together it would take everything possible. All right, example 3. This is another one that I'd like you to complete on your own. A pin is dropped at random onto the rectangular mat, and it's going to land completely in one of the small squares. So what's the probability that the pin lands inside a gray square, and then what's the complement of that? So stop the video, please, and go ahead and do those on your own. Start it up again when you're finished. All right. The probability of landing on a gray square is 9. 9 gray squares out of a 24 total. That's 3/8, which is 37.5%. To find the complement, you'd say, well, 15 are not gray, so that's 15 out of 24, or 5/8, which is 62.5%. However, that's not the most direct way to get it once you know the probability of the gray, because we know its complement adds up to 1, or 100%. So we can take 100% and subtract 37.5% to get 62.5% much quicker and easier. All right, A sample space is the set of all possible outcomes. So here's an example. If we have two coins being tossed, we want to represent the sample space for all the possibilities that you could have occur if you toss two coins. So we're going to show this in three different ways. The first way I want to address is a list. So you can see H is standing for heads and T is standing for tails. And there are four possibilities of what could occur with those two coins. So listing them in this case is pretty easy because it's two coins. They each just have one possibility each, one head or tail, and so it's pretty straightforward. However, once your situation gets a lot more complicated, a list could be problematic because it might be easy to overlook some of the possibilities. So another way you could do it is with a table. You can see that you can list the options for the first coin on the left-hand side in the column. You could get a heads or a tails, and then you can list the options for the second coin across the top. And in the area that's the intersection of those in the rows and columns are all our possibilities, and you can see the list of the sample space is shown in that intersection there. A third way to show it is with a tree diagram. You can see here this first column shows the possibilities that you could get with that first coin, and then the second column with the possibilities extending from each of those first options for the two options of the second coin. And then in the final area you can see, don't forget, nothing actually goes with that point. Some people are confused and they feel like that's the initial toss, but or the initial coin, but there's actually nothing that goes in that spot. So you could create your tree diagram without the leftmost angle-y thing, and it would still function perfectly well as a tree diagram. So the way you get your final sample space elements is to take the two legs of that tree, or the two arms or branches, or however you want to call it, and that forms the item for the sample space. And then we go ahead and do the next set, etc. All right, so now we're going to use that sample space to determine the probability that both coins will land on heads. So you can see here, we would write that probability heads, comma heads. That just means that those are the two options that we're going to get. We're not concerned with order in this case. We're just concerned with both of them end up being heads. So you can see out of our four options listed in red, there's only one of them that's heads, so it's 1 out of 4, or 25%. Example 5. Now we had a set of coins where one face is colored blue and the other is colored green. So we're going to take 3 coins and toss them. So what I'd like you to do is draw the sample space for this scenario as a tree, and then draw the sample space as a chart. Now this is going to be a little bit trickier because you have 3 options here, so you're going to have to be creative about how you create your chart. It's not as straightforward as when there are only 2 things. And then using those, I want you to determine the probability that the coins are going to show 1 blue and 2 green faces in any order. So go ahead and stop the video and then continue once you've completed that task. All right, let's take a look. Here is the tree diagram for the 3 tosses. You can see that there are 8 items in the sample set. Here is the chart version. Now you can see it's a little bit trickier, but you can see the first coin toss is here in this column, and the second coin toss is across the top. And so the white areas here are showing the intersection of those. That would be a blue and a blue. And then the third coin has to be included sort of as a subcategory within each of those rows. So you can see I took the blue and blue option and then added the third coin on there, either being blue or green. That's how it's completed. So the gray area is actually our final sample space, all those gray options. So the probability that you get 1 blue and 2 greens is going to be 3 out of 8, or 37.5%. All right, that's it. Please go ahead and finish worksheet 5 and check it and correct it as normal.